Okay.
That's number 73.
4 years ago.
Alrighty, guys, we are getting close.
This time?
Alright, so 73, we were working on 73. Y'all get it finished?
Hold on.
No.
He talks to us about women in power.
Yeah.
Let's leave it at that.
We don't agree.
We don't want your opinion either. I'm sure. No, the same as his. No. Oh, no.
He says for the sake of my well-being in this class.
What?
Very wrong.
Alright, so y'all get finished up. That's very sad
Oh, I
for me.
did kind of.
So, what were we looking for here? We were trying to find, we're just trying to find X final. We got that final velocity. Squared equals to 2 times acceleration. We made it this far on that problem. We had to stop. Because there's that info.
No.
So let's see. I need final velocity, which we got to be 285
Sure.
kilometers per hour.
I didn't like get this.
Yeah.
Are we gonna have problems like this on our quiz or tests or whatever? Or are we just gonna have forced problems? I appreciate this forced
Should I do
problems.
it?
Y'all want to take this?
For once you learn it, don't forget it, and always put it
He
in.
doesn't
Oh, I'll
tell you.
tell you.
He doesn't tell you what's going on.
And that too, yeah.
Or can he
You can ask questions,
We calculate acceleration.
but he's not gonna completely tell you.
Is that what we left off
Okay, on the probability of whether this will be on the test.
No, we
or not,
did
give me
it.
a
We
percent.
did. I'm getting the information from it because I'm
Okay,
on
what
this
was
sheet.
acceleration?
22.6522 meters per second squared.
We're trying to find X final, right?
Hallelujah, got me something.
For when?
Money.
Charlie Cobb, come to the office.
Who
Who
is
is
it?
it?
Brianna Evans.
Who?
Brianna Evans. She's new. She's fresh out of college, so y'all be really nice.
Okay.
She's the
She's a friend of mine also
I
and
thought
has
she
my
worked at
personal
Subway.
cell phone number. So any issues can be directly sent to me immediately.
Well, I'm sure we
Why not
won't
just
have
ask
the
him?
conversation about women
Said
in
he
power
loved
with
our
her.
class.
I'm pretty sure
Hey.
that we won't be having the
Let's
disagreement. The disagreement we
I
had
hope
with
not,
Mr.
at
Quandell.
Okay, so I don't want to know anything about it.
And going
In
on
this case, we're
calculators?
trying to find X
Wait,
final, and all I did is I moved all that information over. So
Can
now
you
we
wait
can-
5 minutes? Just 5. Thank you very much. How many? Oh, there's one.
I would like
I
to learn
need
as well.
one.
Please
Yeah,
and
I
thank you.
won't want to.
I haven't seen it too.
Please and thank you.
This is where we left off.
I just walked in front. No.
Yes.
No, I had 1/2 AT squared.
You gotta write it down.
No.
You're welcome.
You gotta write it down.
I don't even have a book.
But you
Yeah, I know.
said it was a VF.
I needed this information right over here that was on my front page that this was given to me, this we solved for to get on the front
I
page.
know that. How did you get VF squared over 2A? And then how did you get 2A times XF of the top? Yeah, please.
Okay, so we're sitting here. Let's see. Started here. Get my information.
Okay, and that cancel because there's zeros. Okay.
Good.
Yeah.
Okay. So then I went back here. Had that on the front. Then I moved everything around to get me this. So I could use this equation to find my answer.
Okay.
Alright? Now, we got a problem. Like I said before, sometimes it's good to wait to see if you have to do a conversion. You guys called this ahead of time. So look at this. I got velocity final going to be squared up here, which is in kilometers per hour, and an acceleration down here on the bottom, Well, the denominator is in meters per second squared. What we got to do? Metric conversion. Yeah.
Is it 10 to
So
the
excited for
negative third?
So it's 285 times 10. So the first thing is I'm going to get it from kilometers into meters per hour. Because then when we try to get from hours to seconds, we're actually going to have to divide some stuff out. So I'm going from kilometers to meters. The difference is kilometers is 3, exponential value is 3 minus base unit, which is 0.
Oh. Negative.
So positive 3
I will tell you, I did not do that.
over hours. So now we got to get that into seconds. And I'm going to need a calculator because I can't do it in my head.
Oh, that's just where you got the 0 from the sim, right?
Yeah.
Wait, I did that. Where'd you get the 3? From kilometers?
Kilometers. What's the exponential value for kilo?
2.
10 to the
Three.
third. All right, so in this case, we got to get rid of hours. Hours is on the bottom. So I need hours on top. Cancel them out. So
Meters on the bottom. No. Seconds on the bottom.
60.
Minutes on the bottom.
minutes. Okay.
Why do you minutes?
1 hour. How many minutes are in an hour?
Oh, we have to go hours to minutes to
60.
seconds, right?
So now I got minutes on the bottom. I need minutes to cancel. I need seconds left. So seconds go on the bottom. I shouldn't have done that. Ooh, forget that mark.
60 seconds is in 1
60 seconds is in 1 minute. So now we can do the math. So 285 third power.
Oh my goodness.
Is it not the negative third?
No.
I'm so confused.
Okay, think about it. So remember what I told
It's
you
3
before.
minus 0.
If a quantity of measurement increases, the number has to do the opposite. So in this case, I went from a kilometer, which is really large,
It's small.
to meter, which is small. So the quantity of measurement decreased. What does that mean the number does? The number has to increase.
Okay.
Let me check. I did some. Yep. So we get velocity final. Once I punch that all in the calculator, I get 79.1667. This is meters per second.
Oh.
We haven't even worked the problem out yet.
Nope, we're getting there.
We need to have work for all of that.
We haven't found
what we want
the
to find.
position. Trying to find final position. Now we have the information that we can solve it out, because when you look at it, we have final velocity squared on top, so that new number that we converted, so 79.1667 meters per second
Is that square?
is going to be squared. That's going to be divided by 2 times acceleration, which we have the acceleration we solved on the front.
I don't know what's
Be
happening.
22.6522 meters per second squared. So then we can now punch that in our calculator.
Okay, well now I get
Why does everybody want to look
So curious. What is this class really like? Are all the rumors really true? Does he make kids cry all day long?
Yes.
Y'all make me sound so incredibly awesome.
No.
You are so incredibly awesome.
Thanks for the enthusiasm.
You have that.
Oh, that's not what I
So 7.
So we get 138.3389 meters.
I got like 800 something.
Yeah. 79.17.
What y'all do?
I multiplied 2
No,
times
you-
the 22.6522, got 45.3044, and then divided the 79.1667 by that, and got 1.747.
You gotta square that number.
Yeah, you
Remember
gotta
that
square
velocity
it.
up there, that final velocity is squared.
Oh, okay, yeah.
I'm still not getting the right answer.
What are you typing in?
I put
138.
79.1667 in parentheses, then squared it, divided by 2 times 22.6522. And I got 7,000.
Divided by 2 times what?
2 times 22.6522.
Alright, you punched it in wrong. What's that?
Just give me that.
That's what I can see.
62,
Boone, Mississippi.
3, divided by. Oh, I got that. I done it. I got it right when I done it individually. I can't type it in.
Would it be in meters? Oh my. Ooh.
See, I put 7.22.
Are you gonna have tutoring for this class?
Yeah,
We will.
Please, like before our
This
next.
is
I
X
think when it's
final.
reading, you got that 2 in that division, you need to put those.
But where this is X final, what is it?
Yeah.
Why is X initial? Okay, never mind. I did that wrong. My bad.
Oh my gosh. Oh,
Now type it out the rest.
Alright.
Hey, on that, we will have tutoring, but I had a conversation with some people, and I don't want to single anybody out, but some people were talking that they may, like it would be a little awkward for them if they came to the house, and I get that, so what do you guys think about going to Ray's?
Okay.
Well, you got it ready.
We have like milkshakes to do physics, it's gonna be awesome!
Milkshake, yeah.
Yeah, as long as you buy me something to eat.
Christy, they told me you were just gonna take the money for our milkshakes out of your snack fund.
No.
If we do
Right.
order food, we need to order that at like 1, so it'll be ready by the time we get there.
The milkshakes do take a long time, but I think they're so focused on making it so pretty.
have you tried that chocolate lovers one?
I hate chocolate so much.
Have you tried
Oh,
the red
I don't
velvet?
like chocolate.
He's a
It's-
I
chocolate.
haven't had red velvet, not on.
I've never.
It's
I've
got
never
chocolate
drank
cheesecake
them.
on it, and it's so good.
Chocolate.
Like,
I had the, I want to say the
I don't like
strawberry
chocolate cheesecake because I had a traumatizing experience.
Oh, I love
All right.
soda cheesecake.
Any questions on 73?
Sour.
No, sir.
It tasted so bad.
So that's how we find that distance that we have to travel in order for the jet to take off.
What's,
So with that, I will let you guys know when we're going to do a study session, and we'll meet at Ray's.
what's all the formulas that we have so far?
Somebody chauffeur me there.
I'm with you. Poor man. I think you should just walk.
Yeah, I could.
Call an Uber.
All right, you got x
Yeah,
final
I've
equals
been-
x initial plus initial velocity times
Oh,
time
good
plus
job.
1/2 acceleration times time squared. Then we have final velocity is equal to the initial velocity plus acceleration times time. If you guys have made it far enough in your calculus class, you'll realize that this is the derivative of this. If not,
We have not made it
Let's
that far
have a
at
talk
all.
about that.
then we have velocity final squared equals velocity initial squared plus 2 times acceleration times x final minus x initial, or I like to call it
Ow.
the change
Yeah, I
in
should've
displacement. Then we
Calculus.
have force equals mass times acceleration. We have weight, which is force of g equals mass times gravity.
The farthest we
Anything I'm forgetting, guys?
we know that like
Awesome.
the
What about-
Oh, put that back up there.
Ah, that sucks.
You.
Yeah, no, you just ripped it
Maybe
out
the
like you
head
rip our
problem.
hearts out.
Hold on.
Is normal force?
your finger.
Something?
Huh?
Normal
His
force.
finger's just standing there.
Look.
Normal force is equal to the opposite force of gravity.
Hey, Mr. Hall.
god, oh god.
I love it.
Big Roll, why does your finger look like a toe?
It looks like a little pinky toe. I did not mean to take that many pictures of that. Oh,
Hey, you know what I learned? over
you
the weekend?
rock.
I learned that you could have a surgery done to shorten the length of your
Your
toes.
toe.
Apparently, I need to shorten the length of my finger.
No, it's just the way your nail is shaped, I think.
Thanks, guys.
Hey, I wasn't done there.
Just come get the post-it note.
Connor, where?
Thank you very much.
Mr. Roll, I've had a bad week, so.
You know what would make it better for you?
Give me your phone.
Number 74.
No, wow.
Yeah.
All right, so 74, 873
How
kilogram
big?
dragster.
Is
So we
that
have
what
a
you
mass.
expect us to say when you do this to us?
Be that way, Connor.
Yay!
What,
I expect a
reread?
little bit more
Will
enthusiasm.
you reread that?
A 873 kilogram dragster, starting from rest. Oh, so we know an initial velocity 0 meters per second because it's starting at rest. Attains a speed, which is also known as velocity.
No, that's acceleration.
Speed is velocity of 26.3 meters per second. So we have a final velocity.
It looks like a flower.
In 0.59 seconds. So we have a time.
263 meters.
So on A,
I'm confused.
Is that
find the average acceleration of the dragster. So on A, we're trying to just find acceleration.
The dragster.
Alright, so in this case, I don't have a force. Since I don't have a force, is there any way for me to use force equals mass times acceleration?
No.
No. So how should we be looking to find that acceleration?
The velocity formulas.
The motion formulas. So, I just gave you a post-it note with them on it. Which one are we going for?
Than the post-it
The
note.
velocity final.
Wait.
Velocity final
Done.
equals
Plus.
something.
Initial velocity.
Initial velocity plus acceleration times time. We can do that one, right?
Okay, why can we do this one? Okay, do I have a final velocity? Yeah. Do I have an initial velocity? Yeah. Do I have acceleration?
Oh,
No. Do I have time? Yes. I only got one x in this case. Okay, so acceleration is the only one that's unknown. So
And
now,
that seems pretty simple.
so now we just got to do some algebra, or you guys like to call it magic.
Yeah.
So we end up with acceleration is equal to the final velocity minus the initial velocity divided by time.
Divided by time.
So in that case, we can now just plug everything in.
No. That's kilograms.
Oh,
The
no.
mass is,
Yeah, we don't want kilograms.
no, we don't need it right now. So 26.3 meters
We
per
don't
second
need to.
minus 0 meters per second divided by 0.59 seconds.
I got 44.5763.
I got that too.
Let me look.
Me as well.
6.3.
We get 44.5763
Meters per second squared.
meters per second squared. So
Hey,
there
I'm
is our
something.
acceleration.
How do you know it's meters per second squared?
That's the
Because I
acceleration.
got meters per second divided by seconds.
Gotcha.
And
not a
meters
fraction.
per second squared is acceleration.
Always.
What is it?
Meters, no. Never mind.
Moving on to B.
That would start a
Wait, that was
triangle.
part A.
C. So now 74 part B. What is the magnitude of the average net force on the
Magnitude.
dragster during this time?
Well, at least
F-N.
magnitude is force, right?
F-N.
Magnitude is a number.
Equals.
This is the way to look at it. Magnitude is a number. Direction is sign.
Okay.
What was the formula?
Vectors have magnitude and direction.
Okay.
Are we gonna have a really big number on this?
I have no idea. Hold on, I'll tell you. What
I
number
know
is this? 74B. Yes, you're supposed to have a big number.
I got 39,004.2625.
Alright, now calm down.
Hold
I don't know
on.
how, but I got
39,000?
That's what I got 38,000.
I got 39.
You may have mixed two numbers in your calculator.
Mr.
Hold on,
Rollins, is
how
mine
are
right?
you doing this?
Alright, so on part B, we're trying to find the force. In the case we have the overall acceleration, which
Oh.
gives us that net acceleration, which therefore we can use mass, force equals mass times acceleration, and that's going to give us the net force because that acceleration is the resulting of all the forces. So in that case, we're going to find this net force. In this case, we have a mass of 873 kilograms. Wait a minute. Did I call you out because you didn't say newtons, or did I forget to call you out because you didn't say newtons?
You forgot, because he didn't say Newton.
I didn't say newtons.
You gotta have units. Units matter.
But you
I called
said
you out.
magnitude is the number.
And you gotta have units. Units matter, Maddie, because if we
But
don't
you-
have units,
But you
then we
said-
don't know what the number means.
Mister.
What's the point in the magnitude if you don't understand what it's for?
That magnitude is the number, and then the magnitude is the unit. Did you not? Everybody's gonna think you're mad.
Yeah.
That was a mean voice.
Okay, I would like to add newtons to my answer.
I was sitting in Miss Archibald's room and all I hear is
If we're sitting at Ray's with you talking to us like this, somebody's gonna call the police on you.
you're gonna
Thinking that we got like abducted and forced to.
I will feel better if they call the police. If they call CPS, then they think I'm an old man.
He says, don't forget your units. And they're like,
Oh, thank you. Can I get an extra slice of cheesecake with a milkshake?
they're like,
All right, 38,915.0884.
No. No. Wrong.
No.
1099.
6.
No.
1099.
1099. 10.
You did that stupid answer crap.
Why do y'all type it back in? Just let the calculator work for you. Leave the answer in there, then type the function, and
Because
then it works
it's
better.
easier just to not.
It's easier. I literally hit times 873.
But we're all
If
doing
you
it different.
forget.
I know. All y'all are math minded. None of y'all are science minded. I get it.
I hate
Good.
science.
Oh,
Math
no.
is better.
Oh,
Yeah.
You've been shunned.
So you no longer wrong.
And what units do we have here?
Newton.
Why? Because what's a newton equal to?
4.
Big.
No.
Kilograms times mass times acceleration.
Kilograms times meters per second squared. Thank you.
That's
Whoa.
totally right.
Wait, what does it mean?
Huh?
Kilograms
Mass times
times.
acceleration.
We should start shutting this
Whoa,
off.
kilograms times
Now,
meters per second squared.
that,
Yeah.
I understand. I'm getting a little hostile. But you calm down, Dolphins.
So is magnitude mass times acceleration and then the other thing?
No, magnitude is number.
What's that mean? Then why do we need the unit?
So we can identify the number. If you just, look at me. You had me for chemistry. What happens if you give me a number and not a unit?
It's wrong.
It is absolutely wrong. I may even write on there fairy tinkle toes or something. I
I
don't
was
know.
gonna say, we could have 38,915.0846 chocolate bars.
Exactly.
I would
Why would you make
That's not
chocolate bars
reasonable.
talking about
Part C.
flying through the sky?
Unreasonable amount of chocolate.
But don't judge my chocolate
David
baby,
is one
okay?
of
Pot C is a good one.
None of them are good. This is like sitting in math class with Miss Cole and be like, this is fun.
This is a good one. Ooh.
I'm having a blast, guys. I don't know about y'all. This is great. Now, there's no other way I'd rather spend my Wednesdays.
I'd rather
I'd rather.
Part C. What horizontal force does the seat
You're wrong.
exert on the driver if the driver has a mass of 68
You're giving
kilograms?
me
He
PTSD.
said we don't know an inside
Mr.
voice here.
Hall, do
Yes.
you have ramen noodles on top of your spoon?
Raymond?
Yeah, they've been sitting there forever.
Wow.
Where? I still
Make a brick.
Like, there's probably, like, I don't know if they have an expiration date on it, but there's probably a big spot.
I watched my brother eat a brick of the noodles, not cooked or anything, and then like he
That's
ate
actually
into it and then like put the seasoning into his
That
mouth.
doesn't surprise me.
Yeah.
So like magnitude is
He said,
force,
"What? I
right?
was hungry."
No, magnitude is number. Magnitude is the number of effect. vector. Force is a vector, so we can have magnitude.
Mr. Hall, can
So
you
it's
restate
literally
what
the
you
same
just said?
Okay, so think about it.
No, like the problem. Can you reread the
Yeah,
problem?
absolutely. What horizontal force does the seat exert on the driver if the driver has a mass of 68
What
kilograms?
horizontal force?
So, yeah, so that's why I wrote.
FH.
What?
FH.
Oh, so I'm so proud of you, Chrissy.
Hey, that was
You
a
like
good
when
one.
your forces. That'll be great for the next chapter we get into. So in this case, we're trying to find that force that's being applied. So we're gonna go FH.
From the voices.
Well, did it give you acceleration, or do we use the one at the top?
Oh, why would we use the one at the top?
Because we already found it.
Not the correct answer.
Because it's not
Close enough.
gravity.
Because anything inside
What
the
is that the acceleration of?
the vehicle.
The seat.
The vehicle, and go where you was going, because I think you were going to have it and I interrupted you. I'm so sorry, Connor.
Everything in the car goes as fast as the car goes.
Everything in the car will move with the car at the same speed as the car, and thus the change in the velocities is the same. Thus the acceleration of the person driving the car is the same as the car.
You are too excited for this Wednesday.
I'm Juice.
I'm sorry, I
Whoa. Should have picked better word choice.
That statement. I'm
Who's
sorry
your
I
supplier?
interrupted you, Connor.
You are,
Mass
I don't know.
acceleration.
I love it. I love it.
Why'd you sound like a duck?
Did you say I sound like a duck?
Yeah, when you said mass.
Oh.
Mass. Mass. 68 kilograms.
I can't.
Times the acceleration. And why are we using the acceleration that we calculated up here?
The car was moving at that acceleration.
Because that's what
And since you're sitting in the seat, the driver's in the seat is connected to the car, thus the car.
Acceleration. The same acceleration as the car.
I think somewhere in there between us yelling back and forth there was the correct response.
Yeah.
Hopefully you're watching this video and you can dictate and pull out who said what and that you got
I
right.
want to know,
Yeah.
like, you know how YouTube puts subtitles on videos?
I want to know if it's in all caps.
Put some subtitles on, it'd just be like, yeah.
It says yelling.
Just fine.
It just puts what Mr. Hall says in all caps.
We're going to use this acceleration. All right, all jokes aside, the reason we're using this acceleration is this is the speed, and this is why I really like this problem, is you have to think a little outside the box. And in this case, I am the person that I would give you an acceleration to trip you up in a problem because the very response that was given to me, because that's what we found. Just because you found something doesn't mean you have to use it. Just because something's given to you doesn't mean you have to use it. Think about it. What's that the acceleration of? That's the acceleration of the car. Since, well, the dragster or whatever. Since it's moving that with that acceleration, the person's in the seat. The seat is connected to the car. The seat moves as the car moves. By the associative property, you move as the car moves.
Sure.
You got it?
Could you imagine
I
like,
got
seeing a car take off and like a guy in a suit still just sitting there for a few
3,031.1884
seconds?
newtons.
You got what?
The person is in
I
the
got
seat. The seat is in the car. The car is on the drag strip. The drag strip is in the race
1884.
park.
Yeah.
The race park is in
Newtons.
Yes.
a city.
Don't forget
The city is in a state. The state is in
I get
a
3,000.
country is in a nation.
31.1884.
Continents of the world. The world.
No, not a good job. What did I forget? Newtons.
Hey, we have 3,031
Units matter.
1,884 chocolate bars.
Hey, I've seen a really cool periodic table
Enough
on
about the
TikTok,
chocolate.
Yes.
but it has like the actual elements
what?
itself
I don't
built into it.
Mr. Hall.
No,
I
it's actually
know
called
that Miss
Bravo.
You have a fingernail
Here
clipper?
us. Yeah.
Wow.
Are we doing number 70? We
Seriously.
just did number 70. No, we haven't done 75.
Yay.
What are you gonna throw?
All right, questions on 74.
No,
I
sir.
think they.
I feel like I've actually learned something today.
We need to yell.
Mr. Hall is excited for
Yeah, you
Wednesdays.
need to
That's
go
what we've
more
learned.
often so we can learn.
Oh, that's cool. Where'd you find
On TikTok.
Wait, what?
It's like a periodic table, but it's got like pieces of each element inside the actual periodic table.
that? That's really cool.
Wow.
How would you put hydrogen inside of a?
You would
I want to
It's like
go to a hydrogen farm.
farm?
A mommy hydrogen and a daddy hydrogen fall in love.
Water molecule.
All right.
You go to the
So we got
hydrogen
74 here. All right. Here we go. Now I want.
Candy.
What do you want?
Oh, okay.
That's actually a problem in my head when it's. I really should have the same thing.
Should have a staple gun.
What time do we leave this class?
What'd you say?
12:51. Okay, look, we ain't got time to work this problem, but I want you guys to start on 77.
Okay.
You got 2 minutes. Start on 77.
Well,
I'm looking at you,
Eric
kids.
McClanahan, come to the office.
I don't know how to do it.
Oh, goodness gracious.
Didn't we